Okay, let's look at number of intersections. So we're going to have three possible cases. One solution, meaning one intersection. If the lines intersect, we have one solution. Zero solutions, no solution. And infinite solutions. So let's take a look at two examples. Y equals x minus 3 and y equals, I'm going to move those a little bit farther apart. And y equals negative x minus 1. So we know how to graph those things. The first equation, x minus 3, we have a y-intercept of negative 3, and we're going 1 over 1. So up 1 over 1, up 1 over 1, etc. Perfectly draw it. Then we have the equation negative x minus 1. So we have a y-intercept of negative 1 and a slope of negative 1 over 1. So down 1 over 1, circle the point of intersection, down 1 over 1, down 1 over 1, a negative slope down to the right. And we have an intersection point. And in the next chapter, we're going to learn how to do the algebra to find those intersection points. We just found it by graphing. 1, negative 2. So the first example has a slope of 1, m equals 1. The second has a slope of m equals negative 1. As you can see in the English instructions, we have different slopes, or m is not equal to n. Therefore, it is the first case, one solution, or one sol, one intersection point. So we have a tiny little bit of notes there that are, I don't know why that's there, but it's in something in standard form, and it's just showing you how to remember that if you need to figure out what the slope is, well, you got to get it to be y equals mx plus b. So if, for example, it's x minus y minus 3 or some other general form equals 0, well, we have to get it to be y equals. So instead of minusing x and adding 3, let's just add y to both sides. So x minus y minus y is 0, it's gone. So there, and we can just mirror it. Y equals x minus, above it should say x minus 3. I'm going to correct that in red. Obviously, it said x minus 3 above, and that hadn't changed. So then I'm going to mirror it. So we have y equals x minus 3. And that's how we can get from our standard form back to slope-intercept form, so we can see what the slopes are. And if we have different slopes, we get the first case, one solution. Again, different slopes. Logically, no matter what the x and y intercepts are, they have to intersect at some point in the future. Whoops. Notice I messed up that graph. The point and slopes are not working anymore, but they are in the notes. So let's take a look at parallel lines. So let's take a look at y equals 2x minus 3 and y equals 2x plus 1. Well, we have a slope of 2 and a slope of 2. Let's see what happens. So if we draw the first graph, 2x minus 3, we have a y-intercept of negative 3, we have a slope of 2, up 2 over 1, up 2 over 1. Put a line through it carefully. Then we have the equation y equals 2x plus 1. We have a y-intercept of 1 and still a slope of 2. Up 2 over 1, up 2 over 1. These lines are parallel. M equals m. Infinite NIF solution. The second case. If we have the same slopes, we get an infinite number of solutions. Excuse me. 0 solutions. Erase that down below. Not infinite solutions. 0 solutions. Gosh, obviously, look off to the right. They never intersect. 0 solutions. My apologies. Okay. So shrink that up a tad. Turns out I'm going to have to shrink this blue line up a tad to at least match that. Sorry. So that's 0 solutions. Now let's see y equals x minus 3, and again y equals x minus 3. Well, that's a line with a y-intercept of -3. Excuse me, that's at -2. A y-intercept of -3. I'm just going to confirm that the video still shows that. Great. Y-intercept of -3 and up 1 over 1, up 1 over 1, up 1 over 1. Draw a line through it. Now, draw the other line. Well, they're on top of each other. So they're the same line. So the same line is infinite solutions. So that's the last case. So we have, again, at the top, 3 cases. 1 solution if the lines have different slopes. No solution if they have the same slope and also different y-intercepts. And the last case, if they're the same line, then we have infinite. So 1, none, and infinite solutions. Okay, so now we're going to take a look at a little bit more on points on a line, and then go into the algebra in the next chapter, solving for the intersection point, if there is one.